Here we have a example of Rust crypto differences from MD2 to MD4 to MD5, right? These are all different libraries that you could potentially use. And this particular repo is handy because it tells you the security level. So notice that it says for new applications or where compatibility with other standards is not a concern, we recommend Blake 2, SHA 2, or SHA 3. So you can see here that we have in this particular example, SHA-3, like we call this the later standard. We can actually look at this and see that it's very secure for using in encryption. So now that I know that I can use that library, I'm going to move over here to my cargo file. And if you want to use a particular dependency here, you would just put it into your cargo.toml. And then when you do cargo run, it'll pull it in. So very, very straightforward to pull in dependencies. Now, in terms of what we're going to build here, notice that I have those other libraries, the random, etc. I use the SHA here. Is I want to grab a list of phrases from the book Old Man in the Sea by Hemingway. You can see here I design a static phrases here. And I also add in that there's going to be kin strings that are inside of this. Now, notice I can say, this phrase, second phrase, etc. And once I have these phrases together, what I want to do is I want to generate a bunch of random phrases. So this, in a way, is a simulation to generate a bunch of text where there could be duplicates. Right? That's where the idea here. And so that's what this random phrases does. And again, notice that it accepts or it returns back a vector full of strings. And then all we do is we use this static phrases here and we pull it in. And then we generate a bunch of messages into a vector of strings. Now, the next function here is where we would pull in the power of the SHA-3. So what we're going to do is we're going to create a unique hash using this hash map here. And we're going to say, here's the total number of phrases. And we're going to say for phrase and phrases, go ahead and create a unique hash for that particular phrase. What this does is allows us to really quickly identify duplicates. And then we're going to go ahead and put in a list of the unique number of phrases here and put some more descriptive statistics like total unique duplicates, total combined duplicates, and then basically print it all out at the very end. So that's one of the use cases for the SHA-3 here, is to read in text and then determine whether it is a duplicate or not. So it's a very good tool for detecting duplication. Now, if we go to main here and we look at what's going to happen, this code is going to generate random duplicate phrases from a list of phrases. So in this example, we'll see that it was 24 phrases, and it's going to give you the unique hash, and it's going to say how many times it was able to detect that phrase, and it's going to say how many unique phrases. So in the case of, for example, 10 phrases, in this case, there was only 9 that were unique duplicates, and there was a total of 14 combined duplicates. So like how many duplicate phrases out of 24? So if we look through here, we can actually check this out and we can see it all work together. So all I need to do is type in cargo run and we can see what happens here. So if we run this piece of code, we're going to see that it generated 24 phrases, and it generated, we can see that this phrase was 3 times, the next phrase was 3 times, etc. So it able to see that there was a total of 10 unique phrases, and there was a total of the duplicates that were found. There were 8 different kinds of duplicates, right? So we can see our 1, 2, 3, 4, 5, 6, 7, 8. And then of all of the duplicates, right, if you sum those together, there was 14 duplicates. So of the 24 phrases here, we can see these are the descriptive statistics about it. So this is a nice technique to use depending on what kind of problem you're solving. Maybe you're trying to curate a data set or look at a file system and remove certain files. Fortunately, again, with Rust, it's very easy to build a powerful command line tool that can detect duplicates in text and binary files. And it's all done through existing libraries. And you also can rest assured that it's going to be easy to distribute this because you can do a binary-based deploy. Here we have a incident response diagram for a medieval castle, and we're going to take a look at what an attack against the castle would actually trigger. So having an effective incident response plan is really important to defend the castle. So first up, the sentries would raise the alarm to warn of a breach. Then the captain would coordinate the defense strategy. Next up, the damage and the entry points are assessed. So, for example, are the walls breached or is there a moat that needs to be repaired? So, these countermeasures are deployed to minimize the impact. Once the incident is contained, deeper forensics uncover how the attackers infiltrated perimeter defenses. And the lesson learned improve the security and the response capabilities for future attacks. Training prepares the guards to quickly identify and react to a similar incident in the future. Really, readiness is crucial to defend the castle. So, a modern cybersecurity methodology relies on similar incident response programs. Controls like intrusion detection systems would automatically alert IT teams about suspicious activity, and also response plans would document the procedure for the analysis, the containment, and the recovery from a security event. The coordination with the legal and the PR teams may also be necessary depending on how big of an attack it is. The strong incident response minimizes the damage from the attack, and also by analyzing the trends, you could uncover vulnerabilities to improve the defenses. Finally, if you're going to verify regulatory compliance, it's important to have good reporting as well. So, in a nutshell, if you want to prepare through training and testing, it's going to build an effective response muscle. So, you have the ability to really react from muscle memory. And you want to make sure that your castle is going to readily detect and neutralize any potential breaches. Let's take a look at compliance in a medieval castle. If you wanted to maintain compliance with the king's decrees, the castle itself has to have ways to enforce these decrees. So, for example, the decree could be to boil all the water before it's used, and this could protect the safety of everyone in the castle. And as a result, you need auditors, and these auditors would provide a level of verification for the regulations as well as other things like taxes. For example, somebody has to pay for the auditors, and these are done through taxes. You also would need to verify those techniques as well. So the documentation would prove the compliance effort. So, for example, maybe inside of the main well, anytime you've collected water, you have to notify of the water you've collected. And then once you've boiled it, maybe you do another notification and there would be a checklist somewhere. So the guards are trained on the relevant regulations and shortcomings are identified and remediated before the inspectors arrive. So with a computer system, it's very similar in that you have to comply with rules like HIPAA or PCI DSS. Non-compliance would result in fines or even a loss of public trust. Frameworks would outline the required controls and policies and also implement ways of demonstrating an adherence to the regulations. So audits are a very effective control, and evidence like a system log would provide compliance to authorities, and this allows you to stay current on regulations as they evolve. Another thing is automatic policy enforcement is a great way to reduce error. A checklist is one of the better ones, and this is a way to ensure the continuity even if there is a change in staff. And vulnerability assessments would also identify the gaps. So, in a nutshell, the compliance would provide accountability, legal assurance, and also implement the required controls so that the customers and regulators both are able to trust the system. And this is going to create a smooth business operation.